Hello, everyone. So, we're gonna start this course by discussing a little bit of an introduction to what analytics is. So, a lot of you guys have probably encountered the word analytics in the digital age. It's a fairly new term. If if you look at this graph right here, the term has existed for a long time, but it has we've been using it in the recent decade. It has only been popular around the 2010s, so it's fairly a modern term. You can argue that it's even more modern than the term computer or internet, for example. When we say analytics, we're usually using it in the context of data analytics, and that's how we usually use the term. So, the chart that you see right here, if you're not aware of this is basically a tool, the Google Books Ngram Viewer, where it basically compiles all of the available books in its database, and you can look at how popular a specific term or phrase is. So the blue line that you see in this chart right here, this is showing the term analytics, and its usage has spiked around the 2010s and it's growing in the 2020s. And this red line right here is data analytics. So when you say analytics, it's usually used in the context of data analytics. So the etymology for analytics, if you go back to where the term came from, so it has roots in Latin, analytica, which mainly comes from the Greek term analine. Honestly, I'm not sure how to pronounce this term right here, but it means to release or to set free. But more formally, though, analytics is the process of collecting, preparing, and modeling data for the purposes of revealing useful insights. Data just lying around, so it's not really useful to anyone. But through analytics, this process of collecting, preparing, modeling, and doing all of these is using this data. And from this data, we're trying to reveal some useful insights. It is through analytics where we can make use of data lying around to be able to solve problems, to understand concepts, to reveal patterns, or to even predict the future. We can even go back to the Greek origins of the term. We can use analytics as a tool to release or set free insights that are underneath your data. At its core, though, analytics is basically converting what is data into useful insights. And we're going to discuss more about what insights mean, but insights would come in the form of patterns, forecasts, relationships, decisions, or trends. Analytics helps us condense complex information into a single number. This is basically what statistics is. So, if you have something complicated, you have a lot of information that you want to summarize into a single number that you can use to compare against the same kind of number. This is basically what statistics is. I mean, I'm sort of oversimplifying what statistics is, but you're going to do something similar to this in the course. Its analytics will also involve condensing complex information into a beautiful and intuitive chart, something that you would do a lot in this course as well. So, to be able to communicate information more effectively, the complex information, you as analysts would prepare that into something that's easier to understand in the form of a chart, for example. And this is basically what visualization is, which we will tackle a lot in this course as well. So before we start looking into what analytics is and the what we're using it for today, let's look at a little bit of a history about analytics throughout the years. While the term analytics in its current context, what we're using it for, it's just a few decades old, as we've shown in the Ngram Viewer a while ago. But back then, our greatest minds have been using analytics as a tool for a long time. Back then, they just didn't call it analytics, they just didn't use that term. So it's been used way back before, but one of the earliest uses of it would be back during the industrial age. And back then, economic efficiency was sort of the trend. That's what's important for people back then. So there was a person, one of the greatest minds during that time, an American, Frederick W. Taylor. He had the idea to use data and math to improve his factory's production. So he sort of realized there's some data lying around, and he can use this data to basically improve the efficiency to make sure that the workers' work is more meaningful, the way to make sure that the workers work more efficiently and that their effort is not wasted. So Taylor called this theory scientific management, so didn't call it analytics back then, but it's basically the concept of using data, using logic to improve production, to improve business efficiency. And Taylor's theory, scientific management, was successful in improving productivity while also lessening worker hours. So the photo that you see right here is one of the factories that Taylor apparently consulted in to improve the factory's efficiency. So scientific management shows how even before we were using computers, even back during the industrial era, so we have already been using analytics before we're even using that term for its current context. So what you're looking at right here, this is known as the tabulating machine. So around the 1960s, so after the industrial era, after the war, software for, this was during the 1890s. I skipped a few years there. So Armand Hollerith, an engineer, invented one of the first mechanical computation devices. This machine that you see right here in the photo, this is called a tabulating machine. But if I'm correct, this is one of the later incarnations of the machine. This is not the first version that he created. So this machine was meant to solve the tedious process of processing US Census data. So it's really meant for analytics. And this task would usually take a long time to do, the processing of the census data, because there's a lot of that data. And before they had machines to perform all those calculations for them, they had to do it manually. And before using this machine, for example, it took around 8 years to compile and process all the census data. This machine showed how our demands for analytics have outgrown our brain's computation capabilities. We now need machines to be able to perform analytics for us. Data is just too large at this point. And around the 1960s, software for processing large tabulated data, known as electronic spreadsheets, were created. So this software. A lot of you will be familiar with this. Some of the earliest versions of this software were the LANPAR, language for processing or programming arrays at random, AutoPlan/AutoTab. But these early versions were improved with the proliferation of more powerful computers. When more powerful computers arrived, something more powerful than this machine, for example, of course, like the Apple II. So spreadsheet software also improved. For example, the VisiCalc, the SuperCalc, and the Lotus 123 spreadsheet. If I'm correct, that's for the IBM. And around the 1980s, the most widely known spreadsheet software was released, Microsoft Excel. So it's been around for a long time. It's been improved more and more. And these days, you even have web-based spreadsheet software like Google Sheets, which will probably be the tool that you're going to be using since it's free software. And of course, with the arrival of the internet, data became more and more available. We started to realize the power of information. So we used analytics more and more. It became more and more in demand that we started to dedicate most of our computational power. So the best computers these days are used to process big data. So you're going to encounter the term big data all throughout this course. We're going to discuss more about what that means, but basically it's a lot of data. So data has become so big that it doesn't even fit in the storage devices of consumer electronics. So when you're working with big data, for example, you're working with data that's so big that you're going to access it through the internet, through cloud computing or cloud storage, for example. So this analytics through the years, taking us from the industrial era up until the current time right now. So analytics today is mainly used in business intelligence. So, as usual, analytics is basically processing data to form insights. An example of usage in the business intelligence context would be if you're interested in looking at what your customers are. So, you would use your customer data and to use analytics to reveal insights on who your customers really are, uh, who are who are the people who are buying your product, for example. Analytics is also used in business intelligence to predict the impact of marketing campaigns. So so that they can produce the best marketing campaigns, the most effective marketing campaigns before they even release it. They will first try to predict, try to measure what would be the impact of this marketing campaign. Is this going to have an effect of more people buying your product? Is this going to be a failure, for example? So they will do some prediction insights, and that will also be based on data. And they're, of course, are going to use analytics to perform these. Uh, you also have assessing the risks of business decisions. So, again, based on data as well. One of the insights that you can gain, depending on the data that you have, is you can check uh, if you perform this business decision, for example, if you change a specific process in your business, how is this going to affect the efficiency? How is this going to affect your profits, for example? So, these are one of the things that they would use in the context of business intelligence, what they use analytics for. So, if you are following sports, for example, seen, you might have heard of analytics. So, these days, when they collect data in sports, they don't just collect, of course, they collect points. For example, in basketball, they collect points, rebounds, etc. But these days, they're more interested in advanced metrics at this point. So the photo you're looking at right here is a chart displaying an advanced metric known as PIE. I'm not really sure what it is exactly, but it sort of measures the impact of a player. So it's not just a simple points per game, not just a simple points per how many minutes you played. This would be a sort of complex statistic that sort of compiles the complex information of the impact of a specific player. If you have this player, for example, if this player have a high impact in the game, does this player have a low impact in the game? And they basically use these metrics to assess how effective an athlete is. An athlete is. Sorry. So it's used to assess, of course, the impact of athletes, such as metrics like these. So it's used to predict the outcomes of matches, for example. It's used to optimize training programs to improve how they train their athletes. It's used to prevent injuries. And in the betting scene, which is honestly a lot tied into sports these days, they use analytics as well to give you to predict match outcomes, and so that they can maximize profit in terms of gambling. So not all of the uses for analytics are really as ethical as the other uses. Another domain that analytics is being used a lot is in governance, for example. So, just like how the tabulating machine was used to process census data for the US government, analytics is being used to improve governance as well. So, with the support of analytics, government organizations would use the existing data that they have to formulate efficient projects, pass helpful legislations, and process population data. And you might have seen a lot of charts these days in the news showing the flood control projects, showing analytics regarding that side. And one of the most impactful charts that I've seen in the news cycle, showing this specific graph right here, comparing the number of flood control projects, comparing the amount of flood projects in different cities and municipalities in Cebu City. So this is close to my heart because this is where I come from. And if you weren't familiar with this news right here, so this chart, what this shows, of course, Cebu City, for example, has 47 flood projects, Malabuyok has 41 flood projects, and etc. And this sort of became famous news because Malabuyok, for example, has 41 flood projects, which is close to Cebu City and even more than bigger cities like Talisay City and Mandaue City. And Malabuyok, if you're not familiar, is as seen in this title right here, it's a fifth class town. It doesn't have a lot of people. So this chart right here shows a specific anomaly and how a specific small town like Malabuyuk can have this much flood projects. And if I remember correctly, when I was reacting to this, when I first heard of this news, I was surprised because even if I'm from this province, I haven't even heard of this municipality. It's that small. I mean, no shade to whoever lives here, but it just goes to show that this is quite an anomaly. So this right here is an example of analytics being used in governance. And of course, a specific domain that a lot of you would be interested in, analytics in education, of course. Analytics is being used to build effective standardized assessments, so to create exams that are standardized for everyone, to compare results between standardized assessments as well. They use analytics to process data like that. It's used to compare pedagogical methods as well, which teaching styles are effective, which ways of teaching are effective. For example, you can use analytics to improve that. It's used to improve the curriculum, which parts of the curriculum are impactful, which parts of the curriculum are not impactful, for example. And it's even used to predict student outcomes, for example. There are some analytics projects out here, or some researchers that use analytics where, based on student data, for example, based on their current performance, you can predict what the outcome would be. Does this student become successful? Are they gonna end up as an honor student, for example, or etc.? So they use analytics for that. So for this discussion, so this is pretty short lang, I just wanted to give you all an introduction on what analytics is and what it is being used for today, and sort of give you as well a little bit of an sneak peek in what you're gonna be doing. So that's it for today. Thank you, everyone.